These terms solute and solution are important. Remember, we have mixtures, and mixtures can be either homogeneous or heterogeneous. Here we're saying a typical mixture consists of a smaller amount of one substance, which is called the solute. So remember, the solute is the portion of our entire amount of liquid that is smaller in amount. And it's dissolved in a much larger type of substance called the solvent. And remember, it's solute combined with the solvent, and together they form a solution. We're going to say that a mixture can come either as heterogeneous or homogeneous. A solution is a special type of homogeneous mixture. The solute completely dissolves. Why? Because the solute and the solvent are both either the same polarity or they have the same intermolecular force. And that's what connects us to this theory of likes dissolving likes. So we're going to say, according to the theory of likes dissolve likes, compounds with the same intermolecular force or polarity will dissolve into each other to give us our solution. Now remember, we talked about the intermolecular forces. There are 5 types, but the 4 major ones are ion dipole, the interaction of ions from ionic compounds with a polar solvent such as water. That's the strongest type. We also have hydrogen bonding. Anytime H is connected to F, O, or N, fun, we're going to have hydrogen bonding. Then we have dipole-dipole. Dipole-dipole exists for polar covalent compounds. Now, in between dipole-dipole and the weakest one, there's another force called dipole-induced dipole. This one is not as major as the 4 that we're talking about, but it is considered one of the intermolecular forces. Dipole-induced dipole is when we have a polar compound interacting with a nonpolar compound. Now, finally, the last intermolecular force, which is the weakest force, is London dispersion, or van der Waals, or induced dipole. Remember, the last force is the weakest force. It has these 3 names that we can give it. If you don't quite remember that, go back to the previous videos and look at intermolecular forces and polarity to help you guide you on which type of force a compound has.